Hi, everybody. My name is Fraser Cain. I'm the publisher of Universe Today, and tonight we've got our virtual star party for November 25th, 2012. Is this some kind of holiday for you Americans?
I don't think so.
Not today.
No. Thursday was.
No, not today.
We're all full now.
Happy Sunday, then, I guess.
Yes.
I was actually mentioning this, that we're actually starting to get Black Friday and Cyber Monday deals in Canada, which they've been trying to push them or something, because we don't have Thanksgiving, or we already had Thanksgiving a month ago, so it's pretty funny. Cool. Okay, so we've got lots of telescopes. As you can see, you've got this beautiful view of the moon, which I think we could just leave it on this and just call it a night, I think. So we've got Gary Gonella, who is there's Gary's view of the Veil Nebula with text on it now. There's Gary. We got Mike Phillips, who's in North Carolina. Hey, Mike.
Hello.
And you've got the Pleiades right now, aka
Yes.
M45.
Right.
I think you're the first person who's actually brought the entire Pleiades. It's a challenge to get this in view.
I always try to do something different for you.
I know. It's Pluto, it's Pleiades, you name it.
Yeah.
So we've got Mike Rector, who's got the other view of the moon tonight. And where are you located, Mike?
I'm in upstate New York.
Wow. And I hear it's cold for you guys, but at least it's not hurricaning.
No.
Yeah. We got Roy Salisbury in Las Vegas. Hey, Roy.
Hello.
Got my partner in crime, Scott Lewis.
Hi, everyone.
With an awful lot of hair now.
Yes, it is, but only for 6 more days.
Yeah, and then this is your Movember thing?
This is my Movember. So there you go. All the hair.
It came down from the mountain. And we got Stuart Forman, who's in the San Francisco area, and he's giving us this beautiful view of the moon.
Hello.
Very cool. Okay, so if you've never done this before, what's going to happen is we've got right now 5 telescopes hooked up, live views of various objects, and we will switch around from object to object and give you some background about it and tell you about what's involved to take these pictures and get a little sense of the science behind it. We don't have any of our PhD astronomers tonight, unfortunately, so both Thad and Pamela and Nicole were all busy tonight, so we've got we're going to have to sort of make do with me and Scott. But then, everyone else here. We actually do have a doctor. We've got Dr. Stuart Forman.
That's right.
Yeah, not worth a damn in this hangout, though.
in this situation? Right. If you need to go to the hospital, he'll help you out. So in addition to sort of showing whatever stuff is going to be out tonight, we're also we'll be glad to take requests. We'll be glad to answer any questions that you have. So there's a bunch of places you can post your questions. You can post them onto the event page if you're watching this there. You can post it onto Twitter with the hashtag StarParty. You can post onto YouTube if you're watching on YouTube, or if you're watching this in the Google Plus stream, you can also post your question there, and we will try to get any questions or take your requests and try to sort of show you the night sky. So Scott, what have we got sort of tonight? What's the sky look like tonight for people?
Well, this is for where I'm at. So looking east, we have the moon pretty much right here, up in Aries. And actually, Jupiter.
What kind of moon is it right now?
Well, do you have an app to show us all?
I do. An awful bright moon. I do, yeah.
A very bright moon.
That is a very bright moon. So this is going to be causing us some problems tonight.
Yes.
You will learn to hate the moon like we all hate the moon.
But we all love the moon anyway.
We all love the moon.
And actually over here, we just go to the north a little bit, right above the horizon here. There's Jupiter, just floating up there. Are any of our guys going to be able to pull that in tonight? Maybe.
Jupiter?
Hopefully.
Yeah, I think so.
Oh, yeah.
I'm hoping so.
Yeah, Mike Phillips said he might be able to do it.
Might
And
be
just
grand
above it, you
finale.
can see, and there's Pleiades there above it, right? Which is what Mike's showing.
Right.
So yeah, right now Jupiter's over here in Taurus, and we have Perseus right here, Cassiopeia, Andromeda in Pisces. And northern sky, obviously we're going to have Ursa Minor right here, leading right up to Polaris or North Star. We have Draco, and we have Hercules, Vega and Lyra. And over in the western sky here, with Vulpecula, all
There's
there.
the summer triangle.
Yeah.
Good.
So lots of stuff are up, unless you're in the southern hemisphere, and then it's up to you and in the ground for us. But
Right. You can turn off the horizon if you need to.
you know what? Let's do that. Let's just see what happens. So that's what's up. But it's blue for everyone down in the southern hemisphere right now, however.
Right, with the sun in the sky. That's awesome. All right, well, I'm going to start with Gary's view then. So, Gary, someone's phone is ringing. Is that you, Gary?
Yes.
Do you need to get that?
No. Let me just know something. I'll mute it. Okay, it's been answered.
Okay. We'll wait. You know.
No,
All right.
please, yes.
No, I do not need to get that. They got it in the house. Yeah, this is the Veil Nebula, and I'm going to try to get multiple pieces of it tonight. If you look at this image, I've moved about the width of this image down below for my next shot, so that'll give us a little bit more. The height of the image, not the width. So, don't have any FUDs here to tell us what this is.
Well, let's see if Scott and I can pull this off then. So, if I recall, the Veil Nebula is it's a supernova remnant, a supernova that exploded about 5,000 to 8,000 years ago, and it's actually quite large. The entire thing is called the Cygnus Loop, I think.
Right. Yeah.
And it's a great big supernova remnant, and the thing detonated about 5,000 years ago, and so we're seeing this expanding cloud of gas and dust, and it was so close that it's a big chunk of the sky. In fact, with Gary's view here, you could fit the moon 3 times across the bottom and 2 times up and down, so you can just imagine how big this object is in the sky.
Right.
And so you're going to try and get some other chunks of it, right?
Yeah, I'm moving around in it and getting some. So,
and so each piece of it has got a different name. So there's like the Veil Nebula, and then there's the Western Veil and the Eastern Veil, and what's the other part? The triangle, the Pickering's triangle. Is that right? Yeah.
There's a witch's
Pickering's
broom
triangle.
too, right?
The witch's room, yes.
Right.
So there's a bunch of these different pieces of the nebula that people will view because it's just so large. And so anytime you actually see a full view of the nebula, it's been stitched together by some person who's taken a whole bunch of images and then pieced it all together in Photoshop.
What I really love about this is that just understanding light, that it's actually the brightest feature in the sky if we're looking in X-ray light. So if we're looking at shorter and shorter wavelengths, it would be super, super bright. If we could actually see with X-ray wavelengths in our eyes, this would actually be insanely bright in our night sky for us.
And it was discovered by Herschel, who was the discoverer of Uranus. Is that right? Yeah.
X-ray
Herschel.
vision? That's every
X-ray,
adolescent
yes.
boy's
If you had
dream,
X-ray
isn't
eyes,
It wouldn't be what you think
can't,
it'd be.
right? But you can't because the atmosphere blocks the X-rays. So you'd have to head out into space to do it, and then you would die. All right. Cool. Okay, so let's move on. So Mike, you've moved on. Oh, the double cluster. Okay.
Yeah, I'm going DSO as much as I can before I hit the planets up. So,
Okay.
and I'm
gonna
surprised
make us
this
hungry
Yes.
for your Jupiter image, which is I'm sure going to
Tantalizing,
be
yes.
phenomenal.
I don't want to be a one-trick pony either, so I thought I'd give this a shot.
Get to
You know,
Jupiter.
this-
Come on, man. Jupiter.
Oh, okay, all right. I'm
Yeah,
egged on. I'm egged on.
No. I like all these DSOs. No, I love these clusters.
Right.
I love it. No, please.
So,
Analyze.
so I'm using my 50 millimeter, just a tiny refractor that I use for finding and some low levels of guiding, and I just attach my camera to it. I was able to get the whole of M45, and the double cluster shows it pretty good. This is, I think, a 4 or 5 second exposure.
I love
this
the
is
double
live.
cluster.
I can move it around and everything.
Yeah, I mean, if you've got a pair of binoculars and you want an object that looks really nice in binoculars, this is a classic.
Definitely.
It's it's really easy to find too, right? If you know where Cassiopeia is, that W that's in the sky, right below Cassiopeia is this Perseus. It kind of looks like the spear of stars that come up, and the double cluster is just right in between.
That's right.
Really easy to find, and it looks really nice in binoculars and really small telescopes. So it's
Definitely.
it's one of those first objects to look at. Oh, I see it. Scott's got it here, so we can find the position. Yeah.
So here's
you can see there's-
Perseus, and there's Cassiopeia.
Yeah, and then right in between.
And zoom in
Yeah,
there, nice.
fantastic. Very cool. and then Mike. So we're gonna you got some clouds happening, Mike. Rector,
Yeah,
sorry,
I've
I
got a few
we got
clouds.
two mics tonight, so I'm gonna have to call everybody by name. Yeah, like clouds. Well, I'm gonna move on then.
They seem to be getting thicker as we go on.
All right, and then Roy Salisbury, what have you got here?
That is the Bubble Nebula.
Oh, cool. Again, if we had Thad or Pamela, they would have something really interesting to say. But I instead will use Wikipedia. Trying to remember, I should remember. Okay, right. So it's got so what's going on here is there is a really hot star, is it a Wolf-Rayet star? Right, star with about 10 to 40 solar masses in the middle of this nebula, and it's blowing off this this solar wind, this super hot solar wind of material that's blowing off, and it's forming this bubble shape as the material from the star is impacting the I guess the interstellar material, interstellar medium. Yeah. Really
So
cool.
it's got, you're seeing all this energy, it's pushing all this stuff out. So there's actual mass that's going out there, it's being pushed out from all that energy being given off. And so it's fairly equal in all directions from what we're seeing it. So it actually forms this bubble since it is pushing out in a sphere-like. So we're actually seeing this awesome geometry just being pushed off from it with this emission nebula.
There's some other nebula as well. Like I think in the Tarantula Nebula, where there's like multiple these bubbles that are getting formed by lots and lots of these super hot stars, because these stars are just, like I said, 10 to 40 times the mass of the sun. They've just got an enormous amount of mass, and they've got solar winds, like a radiation pressure that's coming right out of the star that's blasting away all of this nebula material, and so they form these bubbles inside these larger nebulae. But eventually, these things are all just going to detonate too. So they'll turn into more like the Veil Nebula. Same kind of stars. That is awesome. Oh man! And then Stuart.
Sorry, excuse the slewing in the back. This is the blue snowball cluster. I love getting things that Gary can't get because it's so it's so itty bitty tiny. This is very, very heavily cropped, but this is a planetary nebula, and you can see how small it is because if you look at it, I don't know if you can see it on the YouTube screen, but you can actually see the individual pixels around the bluish. But it's clearly blue. And it's fun. It's a fun little bright, tiny little planetary nebula.
Wow.
Well, and for tiny, what's actually crazy is that the actual diameter of it's 20,000 astronomical units. So the distance between Earth and the Sun multiplied by 20,000 times, and that's the actual diameter of this object. But it's just so far away, it looks so tiny.
And that's another planetary nebula, right? This is
Correct.
This is a star that was like our sun that went through the final stages of its life, puffed out its outer layers, and is now in the process of dying and cooling as a white dwarf star.
Yeah, and if one of the PhDs were here, they can tell us why it's so blue, but I can't because I don't know.
But I mean, I think they sent one of the whole main purposes of the Hubble Space Telescope was to get to the bottom of these planetary nebulae and try and figure out what's actually going on in them. I mean, each one is very individual. I mean, you look at things like the Ring Nebula or the Eskimo Nebula or the Helix, and they all have these weird shapes, these different individual unique shapes. This like has something to do with stellar outflow gassing, the way it's rotating, things like that. It's quite amazing. One person's asking, I guess one sider is asking on YouTube, how much zoom is applied on this planetary nebula?
This one is very heavily cropped. The original picture was just a tiny little dot right in the middle of the screen, and if you imagine your computer screen in front of you, I cropped basically. Let's say your computer screen is 11 inches. I probably cropped an inch in the middle of it. That's how heavily cropped it is.
Right, and you've just cropped that in like Photoshop and then just expanded it, right?
Well, I just right, exactly.
You just zoomed in on a little portion of your screen.
Exactly.
I was able to get it too, and you can see here these are stars, these two, and this right in the corner, and this is the blue snowball. I mean, it almost looks like a star in my mind.
Yeah, it's tiny.
Yeah.
But that's on your spotting scope, right?
Yeah, that's on the spotting scope. Right.
Yeah. Okay.
Yeah, and on Mike, on Phillips, on your regular big scope, you ought to be able to get a reasonable view of it.
Yeah, I haven't tried yet. I did the Saturn Nebula recently, and that actually came out pretty good. It showed some detail on the core and stuff.
Yeah, planetary nebula are tough, especially for refractors, because the field of view is so big, and there's only a few of them that I can see.
Oh, there's only a few of the nebula that you can actually get in your view.
Well, just because a lot of them are just so small that this is like the limit of what I can see. We've got the normal close ones like the Ring Nebula and Dumbbell and stuff like that, but there's a ton of them out there, but they're really itty bitty.
How big would the Ring Nebula be compared to this in your view, I wonder?
Probably, I'd have to look at the arc seconds, but just ballparking, probably twice as big, I would guess.
Mm-hmm.
I mean, I can look it up if you're interested. It just take me a sec.
Yeah.
And I see a comment here on YouTube for Basha Bill. It's incredible, it's so beautiful. But how old is the picture we're seeing of the Blue Nebula? So Stuart right now is actually taking these on the fly, but if you're talking about the actual photons that came across space, this is around 1,800 light years away from us. So it took light 1,800 years for it to reach us.
Yeah, and the photo was captured 5 minutes
years.
Yeah. So 1,800 years plus a few seconds.
Right.
Yeah.
Exactly.
Those seconds matter, Stuart.
I love that object.
It might go away.
Well, it will. I mean, a lot of these objects are, we're seeing them. They're very temporary. I mean, we see them now, but they are the sort of slowly dimming, fading objects as the light from them starts to fade away. As the gas gets dispersed much further away, eventually these objects are going to just start to disappear again. I mean, same thing with the Veil Nebula, all of these stuff. I mean, we're seeing a lot of these. A great example is like the Crab Nebula, which it's not up yet, I don't think. But,
No.
it's like, 1,000 years old. And so it's a great, big, beautiful, supernova remnant. But in a few more thousand years, maybe it'll have faded away. So it's all very temporary. But the astronomy that we're seeing, the astronomy that we're seeing now is different from the astronomy that people will see in a few thousand years. And especially if something big goes off, like Betelgeuse, right? Or Eta Carina.
I'm hoping to really get to see a supernova, visible with the naked eye. I think it would be phenomenal to be with the technology we have nowadays to actually watch all these stages fairly close up and watch the progression of it actually happening over hundreds of years.
Yeah. I just looked up the Ring Nebula. It's about 1.5 times as big as what we're seeing in this.
Okay. That's beautiful. I think that's going to become my favorite object. My favorite deep sky object. Just amazing. I mean, just the color. It's so blue.
Mm-hmm. Oh, and the reason why it's blue is because it's with ionized oxygen, so it emits a wavelength around 500 nanometers. So when we're talking about wavelengths of light, the length of that wavelength is actually attributed to different colors, or you go into infrared, which means longer wavelengths, or ultraviolet, which is smaller and smaller wavelengths. So when this is emitting light from the oxygen, it's around 500 nanometer, which gives it that bluish green color.
Alan Curlin wants to know if we can see the Tarantula Nebula in 47 Tuscany. We can't. Those are in the southern hemisphere, so we've been trying to get some astronomers to join us from the southern hemisphere, but it's been hard to coordinate them. So if there are any astronomers located in the southern hemisphere that want to help us out, we would love to get your view of the night sky. That would be wonderful.
It is something that we're looking at doing here starting in the beginning of 2013. We're trying to get a few more astronomers on board and have a regular show, so very similar to what we're doing here, but an earlier time on a Saturday for North America. So it would be actually nighttime in the southern hemisphere on the other side of the globe. So look forward to that, everyone.
And maybe we could even, if we get enough people, we could switch it back and forth. So do 1 week from the northern hemisphere, and then the next next week from the southern and sort of mix it up. That'd be great.
That would be.
All right, I'm going to move back to Gary. So this is more of the
Yes.
of the Cygnus loop.
This is more of the veil. The part we had was up here, off the frame. So this is farther down, and I'm going to try something. See if I can make this work. I'll show you just the size of this thing.
It's the Gonella Nebula. It's my favorite.
Yeah.
Oh, cool. Okay.
So this is the part we were looking at first. This purple box is my camera's field of view. So you can see we're looking at this right in here, and then I'm going to come down and get this piece down below. But you can see as a whole thing, it's somewhat of a circle.
But you can really see, I mean, in this simulation of it, just how it's a blasted, shrapnel from this star going off of several thousand years ago. Just,
yeah, and this
scattering
is,
pieces of material.
for those that are new, this is hydrogen alpha light, which is all I use, a very narrowband filter in hydrogen alpha, and it's a 2-minute exposure. So
apparently we're broadcasting at the same time that The Walking Dead is on. So I appreciate those of you who are joining us while they could be watching The Walking Dead.
Brain. There you go.
There you go. Yeah, exactly.
If people don't have a DVR, then that's their problem.
All right. Well, I'm going to move back to Mike's view. But Mike, your clouds are really dogging you tonight.
Yeah, they came out of nowhere. They were good right before we started, and as soon as we started up, they seemed to attack. They don't like our moon.
I like your moon.
Well, thank you.
Even if it is
Tony Gilkerson, yes, I saw your comment. So if you have a question, we can see it.
Yeah.
Cool. And Mike, I don't see anything. I just see blackness. That's the moon? Mike Phillips. God, too many mics. Mike Phillips.
Not yet. I'm switching between the finder and the main scope here. I gotta.
Oh, cool. Okay. But people can see your telescope there in the little icon that you've got there.
That is the one.
That's cool. And I guess if people haven't seen the on the video that Google did of the Virtual Star Party team, you can see Mike setting up his telescope. Stuart Forman, I've gone back to you. What is this? Another one of your little star clusters?
One of my personal little star clusters. Yes, this is
the Forman cluster.
Right. This is Caroline's Rose, and let me go back to the data on it, or somebody who's on Wikipedia can do it for me. But I just like this one. It's an open cluster, and it's just lots and lots of pretty stars. It's really pretty.
I've never, ever even heard of this before.
Caroline's Rose? That's in Cassiopeia, right?
Yeah, it's NGC 779.
Oh, okay. Okay, so it was discovered by Carolyn Herschel, who was the sister of William Herschel, who discovered Uranus, and also discovered the Veil Nebula that we were looking at before. It's all coming into place. It's a really open cluster. It's almost hard to see from the background stars. Like it's really opened up quite a ways. I guess not much longer, and it'll have completely dispersed into the Milky Way.
Right, and this is compared to a globular cluster, which is a lot more tight.
Mm-hmm.
So it's not a globular cluster, but it's an open, so it's pushed out a little bit more.
Yeah.
I love
debate
that ribbing on that. So
I won't take it.
Nerd joke.
Globular cluster.
Globular clusters.
That's awesome.
I'll take off. I know I'm a hoser. It's all right.
He started saying it, the way the Americans say it. Not long after we started making fun of him. So.
I don't even remember how to say it anymore. Globular cluster. I don't even know.
You got him confused. He's on the run. Get him.
Zed. Yeah. I will be turned into a zombie. Zed. And pasta. There. Chesterfield and Lieutenant.
Now I'm going to have to go and get some milk in a bag, so I'll see you guys later. That is something I miss. I miss getting milk in a bag. Completely off topic, but
All right, let's see if there's any questions here. I don't know what you've got here, Roy. Is this your version of Pleiades?
No, it's part of the North American Nebula.
The resolution is really hazy. I'm not sure what's going on.
Yeah, that's me. I'm trying to get it the image shared through a different way, and it's not coming across. For some reason,
So
I can't
Artem,
get the.
sorry. So Artem Alishin asks, would it be possible to take a glance at Venus at some point tonight, if it's at all visible? And it is not. Where is Venus? Scott's going to show us where Venus is.
Way
down
in the morning.
There. See the grass?
Yeah. So I'm going to work my magic and remove the ground.
Yeah. Oh, but look how close Saturn and Venus would be if they were visible.
Right. So right now
And
they're
there's
over
the
here in
sun.
Virgo.
Yeah. And they're right by Mercury too. So they would rise in the early morning. So if you want to see Venus, just get up in the morning and like just maybe an hour, 2 hours, hour before sunrise, you should be able to see Venus. It'll be the super bright star rising in the east in the morning.
Right. Because the sun's
So-
here going to be chasing it. Probably about an hour or two.
And so you'll see Saturn, and then you'll see Venus, and then if you've got a really good view to the horizon, you see Mercury, and then the sun will rise. So, cool. You haven't changed images yet, Gary, have you? No.
No, not yet. Stuart's
Okay,
got
I'm gonna go to-
Andromeda.
I'm going to go to Stuart's view of Andromeda because it's beautiful. It almost looks like you've removed one of those little galaxies, Stuart. Just like Apple. But, right, so this is Andromeda, the M33?
M31. Yeah,
M31.
it's my field of view is slightly reduced because I don't have my focal reducer on, and so it's clipped on one side and the other. If I had my focal reducer, I could get the whole thing.
And you actually were showing us an image of that you've been working on. Maybe
Yes.
you can display that at some point.
Sure.
Just to show people what it looks like when you spend an hour capturing the same image. There.
There we go.
Nice.
Right, so this is the difference, right? So that other view was, what, 2 minutes of exposure, a minute and a half of exposure?
2 minutes, correct. And this is like
Yeah.
an hour and something processed, and I still need to work on the core. It's a work in progress.
When you say work on the core, what do you mean? You mean you need to go out and take some more images of the...
Well, if you look at this, you see how blown out and white that core is. And it's not supposed to be that way, and it's the reason why the core is so much brighter than the rest of it that if you stretch out and you make the try to bring out the dust lanes, the core is going to get really, really bright. And so what you need to do is to do layers and mask out the core so that it looks more even. And when we get to M42, Orion, that's a real classic example of that because the core is so much brighter than the surrounding nebulosity that if you try to take a picture to get the nebulosity, you're just going to get blown out in the core. And so usually when people do M42, they do pictures of varying lengths and then add them all together in Photoshop.
Right. Sort of HDR style
Exactly.
photos. Yeah. But that's a beautiful photo. It's going to be great when you're done with it.
Yeah, I'm still learning though. So I still need to, Photoshop's a very complicated program, and
Yeah, that's an understatement.
it's hard. It's
Space
hard.
is big.
Yeah.
Space is really big.
Oh, I'm going to move back to Mike's view now. Mike,
Which
you've
Mike?
moved to the big Mike Phillips. Sorry.
Yes,
Oh,
I have,
get this right.
but the seeing is just not very happy right now, and it's making it really hard to focus. So I can get it in a little closer.
I can see it's very high magnification though.
Yes. You can back it out one if you think it might do better.
Well, but this will be good when you bring us Jupiter
Yes.
before the scene goes too awful.
Jump it out. That looks all right. How's that?
All right. Well, I'll let you wrestle with it for a bit. I'm going to go back to Gary. So, Gary, this is the third part of your tour through
Yep.
the Veil Nebula.
Yep, that's correct. So this is the lower part. The middle one, we were up here. So, and you can see all the little wispies. And this, again, is one of those that if you take longer photographs, you can find all kinds of detail in this wispy structure, which looks like cobwebs, looks very small, but it's huge.
Have you made your own composite of that, Gary?
I have not. I keep arguing with myself about it, and so far I've talked myself out of it so far.
Can I talk you into it?
Yeah.
I'll talk you into it.
Well, you're going to do a composite of the entire nebula?
Yeah, I'm going to have to.
Yes, you have to.
Yes, you have to.
In my defense, I was going to take some shots last night, and my guide camera was dead. So I got to get that working because I can't take long exposures without a guide scope.
No, I think that'd be phenomenal. If you want some help, I'm a lot closer to you now, so I can hop over and bug you.
Oh yeah, you are. Huh?
That's right. You've moved into a more reasonable part of the city.
Yes, much more reasonable.
Mike Phillips, Keith Frost wants to know, what is the aperture of your scope?
I'm not muted. I was going to say I can't find the mute button to unmute myself. No, it's a 14-inch telescope. It's f4 Newtonian.
So it's the same aperture as Gary's.
Right.
Oh, there's
different
some nice,
style telescopes.
Yes.
Yeah. There's a nice crater. But I can see you're definitely not your usual seeing. It's
No, winter's approaching quickly, and it makes the seeing just yuck.
Does it really? Winter makes your seeing worse?
Oh my God, yes. Part of it is that with the sun during the day and the lack of a significant body of water makes it really warm, so it's nice for humans during the day. We get to the 50s and sometimes the 60s during the winter. And then at night it drops into the teens and 20s. It's just, between that and the jet stream, we don't have much hope for any real good planetary.
Our seeing is so much better in the wintertime.
Really?
Here on the West Coast. Oh, yeah.
It's pretty Michigan, too, where I grew up. Yeah. It was that's the only time we could actually do anything. Surrounded by the Great Lakes, and all those lakes, it was always humid. You can only do it in the wintertime.
Yeah. Yeah, it's like in winter, it just, especially when it's cold, it just looks like the little sparkling jewels in the sky. It's great. When it's not pouring rain, which is almost always pouring rain. Okay, so SoulSav asked a question, and I think I can try and interpret. I wonder if the effect of universal expansion on how we see a celestial object when they reach the speed of light and getting away from us in transition. I don't know if I can explain what I mean. So I think I understand what you're saying. So you're saying that we're seeing light coming from these distant objects that are moving away from us, and in some cases those objects are moving away from us almost the speed of light. But those objects that are moving almost the speed of light are really billions and billions of light years away from us, so we don't really see very much of them. But what happens is the further away an object is from us, the more the light that's coming towards us is redshifted.
So it's being stretched out.
So it's being stretched out, and so the actual light waves are being stretched out, and so we see the color of these objects change the further away they are and the faster the way they are moving away from us. But that's really only for like really distant galaxies that are moving away from us. From the closer stuff, it's it's not that much of a change, and really it's only those distant galaxies that are actually moving away from us. All the other objects in the Milky Way are all gravitationally bound with us to the Milky Way, so they're not actually expanding away from us. It's just those distant galaxies. But in the case of Andromeda, it's actually coming straight towards us. So,
slightly bluer.
So it's actually slightly blue shifted, because the light is actually coming towards us. All right, I'm going to move back over to Stuart, who has another little cluster.
This is NGC something or other.
I love that one. That's my favorite.
When I dropped it into the hot shortcut, it went into a folder deep in my hard drive, and now I don't remember what it is. So
NGC something or other. Somebody look that one up.
Is that the spotty cluster?
Right.
The whatchamacallit?
Fraser's got a new favorite.
Yeah, sorry, I got a new favorite. I love NGC whatever. I'm gonna do a shout out to John Cabrera, my good buddy. Hey, John. All right, moving on. Somebody has asked for a carbon star, WZ Cassiopeia. I think it's just gonna look like a star.
You're just trying to slip Z into the conversation.
WZ, ZZ.
ZZ.
You're in Canada now, people. Okay. So Nathan Reynolds asks a great question, actually. Where and when is the best place to stargaze in North America?
Outside. In the dark.
Outside, yes.
Outside at night.
Florida. I think Florida is probably one of the better ones. Depends on what you're looking for, right? 'Cause Florida has some dark
Florida?
areas, but they're far enough south, right, that you get to see a lot more things than you would if you at your latitude, right?
But you have to look through soup.
Yeah,
Right.
well, it's humid, so there tends to be a lot of good, steady skies for seeing planets and things like that. So.
In Utah, around Bryce Canyon, is probably the darkest skies in the country.
Yes.
Someone's got
Also-
the radio going, I think. Oh, that's done. That was weird. Okay. Utah, yeah, or, New Mexico, Arizona.
Montana and Idaho as well. Some very dark skies.
Where did Thad go?
Hawaii.
Thad said, there
That's
you go, Hawaii.
driving. He's
Up
driving
here in
home from
northern New York
Colorado.
is pretty good too, when there's
biased.
not clouds.
Yeah. So
Rector's
I
biased.
guess what makes for good seeing? So what are the kind of what's the recipe for good seeing?
I'll give you the secret sauce on that one. The secret sauce on that one is little jet stream, or little to no jet stream. Right? That's key. You tend to be in a high-pressure air mass, so usually it's real clear, steady skies. There's low temperature drops over the course of the night or over a time period that's significant. And very low surface winds. Believe it or not, the surface winds have a good impact on those things as well. So all those things kind of add up to, oh wow, it's not moving, right?
And then also far away from any sort of light centers to get rid of your light pollution.
Right.
You're going to want a no moon.
Well, when we're talking about seeing, we're talking about the turbulence of the air that's actually moving and bending the light as we're coming along. So I know that's a common thing that we're asked for. What do we mean by seeing? We're typically talking about the air between the telescope and the object actually bending and making the light wave. So if I know right now, if you're looking at Mike's image, you can actually see some of the light being wavy, like you're looking through water, and that's actually just the air, the molecules of air actually causing it to just wave along as it's going there. The better the seeing, the less movement that's actually going to be happening.
Right.
But there's, in a lot of places, there's a really neat map, and I think you do a search for like dark sky map. You can get a really nice sort of map of all the places that have very low light pollution, and in many cases, even except for maybe folks on the East Coast, you can with a couple of hour drive, you can drive to a place that's got really dark skies. And if you've never seen dark skies like the Milky Way, you really should, at one point in your life, take a nice pair of binoculars and take some hot chocolate and drive a couple of hours and get a good view.
And then slew that telescope.
Slew that telescope, Mike. All right, so Garrett, we're going to go back to your beautiful view of this satellite.
Yes, that is that's a piece of the North America Nebula. This is down in the Mexico way. We showed the Gulf of Mexico not earlier, but on another show, and that's up in this area. So this is down in the part that you would call Mexico. And again, it's another emission nebula in hydrogen alpha light. There's a whole lot of hydrogen glowing, and what we're seeing right here is about a sixth of the entire nebula. So it's another one of those really big things in the sky.
And this is a satellite that's gone through your field of view?
That is. I figured I'd leave it because it looked good.
Yeah. How often do you get these satellites going through your field of view? We see them a lot from you.
I get them a lot. I've got a wide field of view. As long as if I'm taking late at night, I don't get them because none of the satellites are in the sun. But early in the evenings, I get them all the time. I've got one photo where I've got 3 of them in it.
That's awesome.
What's the strategy to deal with that?
Well,
Shoot him down.
Yeah, the options are is to throw that one away, take multiple exposures. Whenever I put something together that I'm actually going to work and make color, I'll take multiple exposures of 5 to 10 minutes each. This is a 2-minute exposure, what we're looking at right here. And then if I've got multiple, such as 8 or 10 5-minute photos, I can combine them and tell it to take everything that is not the norm. So it looks through the whole thing and it says, okay, this pixel here is really bright on this one, but it's darker on all the others, so make it darker. It's Sigma clipping, I think is what it's called, and it'll remove that.
Yeah. Let's see. So we're going to move on to... Oh, cool. So Mike, I think I see Jupiter. I'll move on to Mike Phillips.
We muted you, Mike. Or I did.
Yeah.
You might need to unmute yourself.
And we've got 4 moons there, which I think, Scott, you can help us see which these moons are, right? So we got Io to the right, and then you got Europa to the left, Ganymede, and Callisto.
Yes.
So Io to the right, then Europa, then Ganymede and Callisto.
Yeah.
That's really cool.
And you can actually see their different brightnesses too there.
Mm.
Yeah.
Well, I find it in the big scope. I thought we'd just pause over here and take a gander.
That's great, and I don't think a lot of people realize, with with almost any telescope, you can see this. This is what you will see in a lot of small telescopes.
Yeah.
You get the planet, like a nice big disk of the planet. You see a couple of bands across the face of the planet, and you'll get the moons, which is really cool. And this is what Galileo saw when he first turned his telescope on Jupiter.
And the
and
ears.
the ears of Saturn. Yeah. But this is why it's named the Galilean moons, because these are the 4 big moons that Galileo first discovered. And that was one of the...
Interesting note. You can see this better with your eyes than the camera can do it. Your eye has much more dynamic range. You can actually see bands on the planet and the moons. Mm-hmm. If he reduced his exposure to the point where we could see the bands on the planets, we wouldn't have the moons.
Yeah. It's phenomenal. If any of you get a chance to actually look through a telescope, it's phenomenal. I know if you're out here in the Los Angeles area, sometimes you can go to the Griffith Observatory for free, and they allow you to actually use I believe they have a 12-inch refractor up on top, and a lot of times they have it pointed at Jupiter just for the fact that you can resolve it with your eyes, and it's beautiful.
Yeah, Jupiter is like one of the, be able to see Saturn, be able to see Jupiter and the moon, like that's a small telescope. That's a reason enough to buy a small telescope, to be able to see those 3 objects. But then you can see other stuff too. Stuart, have you changed? Or is this just another one of your clusters?
No, this is the NGC something. I'm trying to get the Cocoon Nebula, but I am not able to get it, so I'm going to give up on this one and try for something else.
Maybe it turned into a butterfly nebula. And You're welcome, Internet.
Okay, so we've got a question here from Kim Serenity. What is the closest black... Oh, no, sorry, someone else asked that question, I think. There you go, okay. Guillerme Lessa wants to know what the closest black hole is. Cygnus X1?
Yeah, it's going to be the one in our Milky Way galaxy in the center of it.
No, but like a regular black hole. Not a supermassive black hole, but the closest black hole. Cygnus X1, I'm thinking.
That's one of the famous ones we know of.
Yeah. The problem with black holes is they're hard to see.
They're so hard to see.
Since nothing, not even light, can escape their grasp.
No, it's a great question. I don't know off the top of my head.
Maybe I was reading an article over on IO9. Maybe in the trapezium. It's about 1,600 light years away.
Unless you're talking about quantum levels where they're popping in and out of existence all the time, then all around you, and it hurts, but it doesn't hurt.
Oh, look at this moon! Wow.
Stuart
is bringing the moon. Now,
Sorry,
do you have
Rector,
Jupiter
you
up
can go
yet,
home.
Stuart?
No, well, it's up, but it's below the trees. I'm not going to be able to get it for VSP for probably another couple months. Mike's our Jupiter dude right now.
Yeah,
Yeah.
I got it. It's coming up in 1 minute. Yeah.
All right. No
Patience.
pressure.
I'm the late one, remember?
That's our whole shtick with you and these things is you bring these at the last minute. Someone's asking how you zoom in astrophotography without having an ocular. So
great question.
When we say zoom, yeah, that is a great question because we're playing all kinds of tricks here to be able to zoom. So we're doing. So it all depends on how the image is being displayed, and so if you've got a telescope and you want to, and I'm air quotes, zoom, you can change your eyepiece. And so if you change your eyepiece, then you'll get a different field of view in the eyepiece. You can also put in a Barlow lens, which will sort of multiply the size of the objects that you're seeing. So it's kind of like zooming. But a lot of cases, like what we're doing with Stuart, for example, he's got he's doing it digitally. So he's got his digital camera is connected to his telescope, and then it's viewing the whole moon, but it's a very big CCD chip. And so then what he's able to do is he's able to digitally just go into different spots on his image, and so make it look bigger.
Right. So I'm just zooming around it right now, just like this.
Yeah, and so this is actually this is the native size of the image. This is what it looks like
right there.
Yeah, so that's the whole image. That's what his whole camera is able to take, but because there's a lot of information in there, he can actually zoom in. And just think about like your digital camera. If you take I don't know about you, but like I've got a camera that would say 5,000 pixels by 3,000 pixels, and then here in the virtual star party, we're only able to pump out a few hundred pixels on a side because of the resolution of these images. So he's able to just zoom in and make it bigger and smaller.
Or if I'm gonna to put it what you just said in one word, it's crop.
Crop.
Yeah. That's what we do.
He's cropping. Yeah. So, but in some cases, people are doing it with just with the telescope itself, and in other cases, they're doing it just by cropping the image in different ways and zooming in. Okay, here's the Jupiter. Wow.
Yay! It's terrible seeing, but that's par for the course now. It was great when I was getting up in the morning. Nobody wants to have a star party in the morning with me, but that's the way the cookie crumbles, I guess. So
it's weird. The smaller image, the thumbnail one, almost looks better.
Yeah, I come back to this is the 5x Power Max. This is like 9 meters of focal length. It's literally like 9,000 millimeters. So
yeah.
Maybe go a little less to see how it looks. But you can what you can see though, even though it's murky, is the south equatorial belt here, and then the north equatorial belt, and then I think this is the north temperate belt. So there's kind of a small little zone in between that, like north, south polar caps.
Keith Nelson says, "I have an 8-year-old here who really wants a telescope of his own. What's a good starter scope for kids? Like, he's just cool, but it won't break the bank." What do you think?
I would go to telescope.com, which is Orion, and there's you can get like a 4.5. I don't have it in front of me, but like a 4.5-inch Dobsonian scope for just a couple $100.
Yeah, if that. Yeah. Let's see. So here's my little telescope.
Also check Craigslist.
Yes, Craigslist is great. As long as it's not just Reebok's Christmas presents that they bought from Walmart. If you can actually find a decent one there that you get a good manufacturer. So this is a Celestron, right? But it's a 3-inch telescope, and it was $50. So it's great to see the moon. It'll see Jupiter. You'll see the rings of Saturn. It's a good little telescope. If you wanted like something a little more serious, then I've got a 4-inch with a nice mount, and that you're probably you're looking at about, as you said, about $200 or so.
And that's about as much as I would spend. Let them wait till they get a job of their own and want to get into this hobby more seriously. But a lot of cases the mount is really nice. If you got a nice go-to mount, you can point out a lot of objects and it'll just move from object to object. But it's very fiddly, and so that's why I really like Stuart's recommendation of getting the Dobsonian. You actually have to learn the sky and
Exactly.
around.
Right. I did that for 10 years before I got a mount that can go to, and I really learned the sky. Get a good star atlas. There's some really nice, reasonably good beginner ones. One is called Night Watch by Terence Dickinson, I believe, which is wonderful. And it only shows you the bright stuff. And get yourself a Telrad, which is or some sort of finder, and learn the sky that way. It certainly helps to be in a darker location.
Yeah, totally. I'm gonna go back to Gary for a second here. Is that another satellite, Gary?
Yes, that's why I left it. That's a 1 minute propeller. And you asked me how often I get the satellites. Well, that kind of answers the question. Here's the 2-minute exposure that I just did. You can see it's got a little bit more contrast, and it's coming up right about now.
Nice.
Ooh. So that's our famous, our friendly propeller nebula that kind of feels like home.
That's great. I love that object.
Yeah. Here I can zoom in a little bit too.
Any idea what's causing that? What kind of object is it? Is it a?
It is an emission nebula. It's a glowing hydrogen.
But so it's not like some kind of planetary nebula. Like it's not like some sort of outflowing gas that's causing these propeller shapes.
No, this is part of when you look at the Milky Way, you see the dark areas and the bright areas. This whole area is just full of nebulosity. It's just a lot of hydrogen sitting around there. And some of these dark areas would be where a shock has caused them to start compressing and building solar systems, building new stars. Why it's that shape, I don't know.
I think it's a fluke, yeah. Back to Mike here. Oh, that's good, Mike. I think this is a better, less less zoom.
Yes. Now I want to show you something interesting here. There's these 2 moons off to the left. I think there were actually 3, but let's go for. Yeah, I think you can tell they're a different brightness and also a different size. So I don't know if you know this, but the Galilean moons are different sizes, and you can actually observe them as such. So which one was which here? Okay. Scott, help me again. I would imagine Ganymede's in the upper left here.
Well, it was. I'm trying to think. It was. Europa was right next to the planet.
That's
and
probably
then
the
it
one
was Ganymede and then Callisto.
And then Callisto, right. Io was on the opposite end.
Yeah, and Io was on the other side of the planet.
So I thought that was kind of neat.
But that Jupiter is your seeing seems to have improved a bit.
Sure it will eventually. By morning time.
Stay up all night.
Well, so the other problem too, and we were talking about seeing, right? And the real hardcore definition of seeing is the steadiness of the atmosphere, and there's a measured scale, either Pickering or other scales. And typically, the seeing gets best as the object that you're looking at is at culmination, not overhead, but it's at its highest point in the sky, right? Like noon is for the sun. Mm-hmm. And I'm not there yet. I'm still shooting over the house by about 15 degrees, so that does not help my case at all, because I'm trying to keep the kids warm inside. So.
Right, and so what Mike means there is that it has less atmosphere to actually travel through. So that means there's just less molecules of air in between it, so there's going to be less wavering.
Still, no, that's a great Jupiter.
Yeah.
It looks good, right?
For it. Yeah, it looks good.
Wait till we get some steady skies on a Sunday night. It's never going to happen.
That's I know. We take what we can get. We've seen all the planets. Actually, we still have never seen Mercury.
I missed it this year, actually. And but okay, so something to look for everybody is every year since I think 2008, I take all of my best images of all the solar system objects and put them together in kind of like a yearly, year in review kind of solar system mashup thing. And so I missed it this year, but that was actually a little thing that Mike Solway had done many years ago, and I think he's since gotten out of it a little bit, but I missed Mercury this year, but I got I think 3 asteroids and 2 comets, so maybe that'll make up the delta. But by December, I'll put that together and post it.
Oh, that'd be great.
Yeah.
This is not one of my best ofs.
Your Jupiter animations are mind-bending.
Thank you.
Yeah. If you haven't already, definitely make sure you check out Mike Phillips' feed, and he's got some animations that he's done of Jupiter where you can actually see the moons rotating in front of the planet. Oh, it's just amazing. So much work too. Like
It
how
is a lot of
long
work,
is the-
and I've automated a lot of it, so which helps out a lot. It's almost a necessity to do that, because you end up with, so what I do with my camera, I end up with like 10 or 12,000 sub images for just a single run, right? That makes up a single image, and then you need multiple images to make the animation. So it's a data management nightmare, and it's a processing headache.
Yeah,
but
you're filling up hard drives, ruining computers, but it's some of the coolest space stuff I think I've ever seen, and it's coming from a hobbyist as opposed to the Hubble Space Telescope.
I got a question here on YouTube, or actually maybe that is Google+. It's Mary Margaret saying, newbie here, are nebulas in our galaxy, or can they be outside of it as well? And that's actually a fantastic question. Up until 100 years ago, we just called everything that was out there beyond our solar system that looked nebulous the nebula. We just looked at Andromeda earlier today, and it was the Great Andromeda Nebula. But now that we have a better resolution, can actually see that there are actually completely other galaxies outside of the Milky Way. We've designated those as galaxies. So the ones that we're typically seeing, that Gary's been showing us tonight as well, are actually within our Milky Way galaxy. Anything further out, those objects, all we can really resolve are completely other galaxies, which are 180 to 200,000 light years across. So they're immensely huge, and what we're seeing here are fractions of a light year across, or some of the larger ones can be a little bit larger, but nothing nearly to the size of those galaxies that we're seeing.
Yeah, and so any of the nebula that we're seeing, they're all going to be in our Milky Way, but astronomers with good telescopes can resolve nebula in other galaxies.
Right.
And so, like, one of the classics is the Tarantula Nebula, which is located in the Large Magellanic Cloud? Small Magellanic Cloud? Yeah. So there's some amazing nebula that are seen in other galaxies, but we're not able to resolve them in these star parties.
Definitely.
Like the Hubble Space Telescope and such. Oh, that's great, Mike.
Let me ask you, is this any more round than it was before?
Yeah,
yes, it is.
Way more round.
Yeah.
Okay, so Webcam Max is doing something ugly to my stuff here. So.
Yeah, I found that too. It stretches and squeezes.
Yeah.
Question is, what filter is good for a nebula viewed with a Dobsonian?
Depends what you're looking for.
Yeah, I would. If it depends on it depends on how you're looking for it. So if you're just looking with your eye, I probably wouldn't do any filter. There are nebula filters that will darken the sky and pop out the nebula a little bit, and I believe they're just called nebula filters. Lumicon makes one. I can pull it out and look at the name of it if you're interested. But it's basically just a nebula filter, and it pops out the nebula a little bit but darkens the sky.
I think it's a UHC filter.
Right. Mike, you're Mike Rector. You've completely lost your sky now. I think I can just barely make out a crater on the moon.
Yeah, I keep getting patches where it pops up, and I get all excited. I look up, and it's gone.
Well, we're sort of closing in on the hour, so why don't we start to wrap this up? So I'm going to see what Gary's got here.
We have the elephant trunk.
The upside-down elephant trunk.
A 2-minute exposure.
That's
and again,
nice.
This is hydrogen gas, star-forming region. The darker, from what I understand, the darker ones are actually dark clouds in front of the hydrogen glowing area.
That is beautiful.
But
it's upside down from the way we normally see it, because usually it looks like the trunk coming down. But
yeah.
Yeah, that's beautiful. All right. And then, Stuart, you've got another one of your clusters? Stuart's
Yeah,
cluster, the thingamajig cluster?
Yeah, no, this is M52. And I'm just sort of trying to hunt for stuff we haven't looked at before, and don't think I've seen this one. And the thing about clusters is they get a little dull after a while, and I'm trying to find ones that are a little more interesting.
Isn't the bubble nebula right near there?
The clusters look great with the color camera that you've got, when you can really start to make out those different colors of stars in the cluster. I think that looks really great. Yeah, some of them are yellowish, and some are white, and some are bluish.
Yeah, you can kind of see it in the zoomed-in view a bit.
Yeah,
it's a bit noisy, but
yeah, there's two kind of in the lower, slightly leftish positions, and right on top of the other. One of them's kind of white, and the other one's kind of blue.
Yeah.
That's neat.
That's fantastic. Cool. Well, why don't we wrap this up then? So, thank you to everybody that joined us and watched us tonight, as always, and deciding to stay with us as opposed to The Walking Dead. We really appreciate that. And now we'll all go watch The Walking Dead too. So, thank you very much to Gary in Los Angeles. Thanks to Mike for braving those terrible temperatures. And joining us again with that wonderful telescope. That Jupiter is phenomenal. That's an unbelievably beautiful Jupiter.
Yeah, that's a good one, Mike.
Very nice.
Yeah, that's wonderful. Look at that. People are... man, that is a wonderful Jupiter. Yeah, wonderful job. And thanks, Mike. Sorry about Mike Rector. Sorry about your seeing tonight. That's
well, the weather lied to me. It kept saying it was going to be clear.
Beautiful, clear. Get out your telescope. Brave the cold temperatures. And then, you lose it. So, all right. Well, and thanks, Scott.
Yeah.
Next week you should be shaved again.
I will be clean shaven again next week. So, look forward
Happy
to
November. And thank you very much, Stuart, for joining us.
All right. Take care.
Relatively warmer West Coast. So, we'll see you all next week.
Hey,
Bye,
good night, guys.
everybody.
Bye.
Good night.